Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5. It says the reaction of 15 grams of an impure sample of calcium carbonate. Then we are given the chemical formula. With excess hydrochloric acid, note that the hydrochloric acid is in excess, and then of concentration 1.0 mole per dm cube is used to investigate the rate of reaction. The balanced equation for the reaction is as follows here, and then we are told that the volume of carbon dioxide produced is measured at regular intervals. And then you'll remember that we spoke about it, that the gas most of the time will be our measure of the rate of reaction, because it is the one that escapes the reaction vessel. And therefore, if we can measure how much of this gas is produced, then it can be able to tell us about the rate of reaction. Then a sketch graph representing the total volume of carbon dioxide gas produced as a function of time is shown below. Then 5.1 is just simply saying define the term reaction rate. So we already know the definition. We say reaction rate. So reaction rate for 5.1, say reaction rate is the change in the concentration of the reactants or products per unit time, right? Then that's just how we go about with the definition. For only 2 marks, we say reaction rate is the change in the concentration of the reactants or product per unit time, right? And then let's proceed. So we are given 5.2. It says, give a reason why the gradient of the graph decreases between T2 and T3. Remember, when we speak about the gradient, I said we are mainly talking about the reaction rate. So when we are asked anything on the gradient, we know that that refers to our reaction rate. Remember, when we are looking at the rate of reaction, we are simply looking at the gradient of the graph. So we say the more steeper the graph is, that indicates a higher reaction rate, and the less steep it is or smooth the graph is, then it indicates a lower reaction rate. Then we just want to check what's going on between T2 and T3. And then if you can check between T2 and T3, we can see the graph smoothen out here. And then we can see that it is becoming smooth here between T2 and T3, which would obviously indicate that our gradient is decreasing, as they're saying, give a reason where the gradient of the graph decreases between T2 and T3. So now we are mainly looking for the reason why it is decreasing. So we can say it is decreasing, meant to say it is decreasing because the rate of reaction is decreasing. So we can say because the rate of reaction is decreasing as well. And then we do understand that with the rate of reaction decreasing, that means that the reactant there is also being used up, right? So the concentration of the reactants are decreasing, right? So because the reactants there are being used up, so hence we see that our reaction rate is decreasing, right? Then let's move. We have 5.3. It says changes in the graph between T1 and T2 are due to temperature changes within the reaction mixture. 5.3.1 says, is the reaction exothermic or endothermic, right? So now, looking at the changes between T1 and T2, we can see that the graph here is becoming noticeably, the gradient of the graph is becoming noticeably steeper. So that means the gradient is increasing. And then we know if the gradient is increasing, that means the reaction rate is also increasing as well. But then when we go back to the factors that affect the reaction rate, we do have temperature as a factor, and we know that temperature affects the reaction rate if the temperature is increasing, right? Now, that means if the temperature is increasing, we would end up having our reaction vessel being hot. The surroundings are hot. So that means that will prove that our reaction is exothermic, right? So for that, we just say, number one, we can tell that 5.3.1, we will go with exothermic. So that's an exothermic reaction as a result of the temperature increase, right? Then we say for 5.3.2, explain the answer by referring to the graph. We will say the gradient is increasing there. So when the gradient increases, this is indicating an increase. So we'll say indicating an increase in the reaction rate. Indicating an increase in the reaction rate. Indicating an increase in the reaction rate. Now, we do know that if there is an increase in the reaction rate, this would mean that the temperature has obviously increased. So temperature increases, right? So temperature increases because we know a temperature increase results in an increase in the reaction rate. And that's just basically how we would explain this. So that means each and every point here would be awarded a mark, and just like that, you have earned yourself 3 marks, right? Then let's proceed to 5.4. 5.4, they say the percentage purity of the sample is 82.5%. Then calculate the value of X, and then we can see that the value of X here indicates the volume of carbon dioxide when the reaction has came to completion. Remember, when the graph starts to flatten out, we say it means that the reaction has came to completion. So reaction has came to completion here. So we do know that if we start having our graph being flat like that, that indicates a constant concentration, and that could also mean that the reaction rate has came to completion. So we can see that the volume of carbon dioxide there is no longer increasing. It has reached a stop. Now they're saying we must calculate the volume of that carbon dioxide that is produced, assuming that the gas is collected at 25 degrees and then Celsius, which is standard temperature. Then take the volume, the molar gas volume, meant to say at 25 degrees Celsius as 24,000 centimeter cube. Now, looking at the SI unit that we are given for volume, it's in centimeter cube. So that means we can just pretty much leave it like that and not convert this 24 and not convert this molar gas volume. So we won't convert this 24,000 centimeter cube, since we can see that the volume that we want there, it's also in centimeter cube, right? But then we do know normally when we calculate, we should convert our centimeter cube to dm cube. But then for this specific question, we're not going to convert anything. Now, centimeter cube to dm cube is usually divided by 1,000, right? Now, let's calculate. This is 5 marks, and then this obviously will hint onto our stoichiometric steps, which is we did speak about those ones. We said step number 1, you have to calculate the number of moles. So step number 2, you have to use the coefficient ratios so you get to the chemical formula that you want. And then step number 3, that's when you now calculate for the required value that is obviously asked in that question, right? But then now we do have something here that before we consider those 3 steps, we have to actually figure out the fact that we are given the percentage purity of the sample. Now, this 15 gram here represents the 100%. right? So this is the 100% sample, which is impure, right? Now, the problem with an impure substance is that we cannot react with an impure sample, right? Before we can react, we have to make sure that we remove all the impurities, and then we put that particular sample into the reaction vessel. So now, hence, we are given that 82.5% is the pure substance out of this impure sample, right? So now the first thing that we have to figure out here is that how much in grams is actually pure, right? So we are given in percentage, so we'll say 15 times 82.5 over 100, right? So it's the same. You can say 82.5 over 100 times 15. That's just one and the same thing. Then if you multiply there, you will end up with 12.375 gram. So this 12.375 gram represents 82.5% of the calcium carbonate, which is actually pure. This is what we're going to be using for the calculations, right? Then we go with step number 1, which is obviously to calculate the number of moles. So we'll say calculate number of moles. So remember, you won't be required to write the steps like this. This is just me taking you through all those steps. Then now that we have this, we can choose the formula N is equals to small m over big M, since we do have the mass. And then that's 12.375. Now, consulting your periodic table for the molar mass, we know the molar mass of calcium carbonate will give us 100, because calcium is 40, and then the carbon is 12, and then oxygen is 16. So if you can say 40 plus 12, then plus 3 multiplied by 16, you're going to get 100 grams per mole, right? So that's where we get that 100. And then N is equals to 0.124 rounded off to at least 3 decimal places. Remember, you don't want to round off to 2 decimal places as yet, because that's not the final answer. So now you have your number of moles as 0.124 mole. And then step 2, this is where now you use the coefficient ratios. So use the coefficient ratios. Right. Now, why are we using the coefficient ratios? It's mainly because we do realize that we are not looking for the number of moles of calcium carbonate, but then we are trying to reach to the information for carbon dioxide. So what we do is we compare the ratios so that we get to that. So ratio of calcium carbonate to carbon dioxide, when we check our balanced equation, we see that it is 1:1. Now, a ratio of 1:1 simply means that what we have as the number of moles of calcium carbonate will essentially be the same number of moles for your carbon dioxide, because they share the same ratio. So 1:4 mole, right? So also the number of moles of carbon dioxide will be 0.124 mole. Now, at this point, you want to do your step number 3, which in step number 3, this is where now you'll be calculating for the required value, right? So this is where now we go back to the question and reread, find out what is it that we were actually looking for. So it says calculate the value of X, which we did say the value of X is the volume of the carbon dioxide after the completion of the reaction, right? So step number 3 is calculate for the required value. Calculate for the required value. Now, how do we calculate for the required value? Remember, this gas is being produced at 25 degrees Celsius, which from our understanding, we know that that's standard temperature, meaning that the gas is produced at standard temperature and pressure. And then the only formula that we have to consult if we are told that this is occurring at standard temperature and pressure is N is equals to V over Vm. Note that when it comes to your reaction rate, always your gases will be produced at STP, right? So you will always have to use this formula. Then this is 0.124 is equals to V. Remember, the 24,000 is our molar gas volume. So where does it go? It goes to Vm. Note that this time around, we shouldn't be using the 22.4 because we are told take the molar gas volume at 25 degrees as 24,000 centimeter cube. So because we are told to take our Vm as that means we no longer use the 22.4 for the specific question. Now, when you cross multiply that, it gives you 2,976 centimeter cube, right? And then there you go. You have your volume just like that. Now let's proceed to 5.5. It says, how will the reaction rate change if 15 gram of pure sample? Now we are given 15 gram of pure sample of calcium carbonate reacts with the same hydrochloric solution. Choose from increases, decreases, or remains the same. Now, if this was any other substance like hydrochloric acid, we would be speaking about the concentration, because you do realize that in the first encounter here, the only mass that we had to consider is 12.375 gram, which was the pure sample, right? So we would say that the concentration was increased from 12.37 gram to 15 gram, but then that would be incorrect, mainly because here we are looking at a solid, right? And then solids, we never explain solids based on concentration. So when it comes to solids, we have to explain based on the what? The surface area, right? So always note that with concentration, we only consider only aqueous solution and gaseous solutions only, right? So for the concentration, it's aqueous solution and gaseous substances only. But then we can never explain concentration on a solid substance, right? So that means this would have to be an impact on the surface area. We would have to say the one that is impure obviously will have a smaller surface area, because remember, it still has impurities, but then the one that is pure is already refined, so that means that one is a larger surface area. As a result of that, we do know that a larger surface area leads to a higher reaction rate. So how will the rate of reaction be impacted? Obviously, it will have to increase. So for 5.5, we say it increases as a result of what? As a result of the surface area, which is what we are asked in 5.6 to explain. So in 5.6, it says use the collision theory to explain the answer to question 5.5. And then note that the factor that is being investigated here, or the factor that is contributing to that increase in the reaction rate, is the surface area and not the concentration. So why not the concentration? It's because that is a solid, and concentration are only for aqueous and gaseous substances, right? Then, okay, so now we have to explain and say an increase in the surface area. So an increase in the surface area increases the collision frequency. So increases the collision frequency, because we do understand that with the larger surface area, more particles are exposed. So we can, if we put that there, more particles are exposed, right? And then since more particles are exposed, that means there are more particles with correct orientation. So more particles will collide with correct orientation. Will collide with correct orientation. And then, obviously, this will lead to what? More effective collisions per unit time. So leading to more effective collisions per unit time, right? So more effective collisions per unit time, which obviously this will have to increase the rate of reaction, right? That's how you are just supposed to explain this, right? So make sure that you play the video as many times as possible and try to understand the approach that I took into answering all these questions for a total of 15 marks. So with all that being said, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, what are you waiting for? Please smash the subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.